very often when naming chiral compounds, it's important to indicate what configuration the molecule is. And so we're going to talk about that specifically in this video. All right, so the naming of chiral compounds is very much the same as naming non-chiral compounds. It's just that when we're naming it, we add the configuration of the chiral center to the beginning of the name, and we put that in parentheses. So in the other naming videos that we'd have done, we might have called this 2-fluoropentane, but it is in fact chiral, and so if we wanted to indicate specifically one configuration or the other, in this case because I have the fluorine drawn on the wedge, it would be 1, 2, 3, so this is in the R configuration, so the name would be R2-fluoropentane. If there are multiple chiral centers in the molecule, then we need to specify the configuration of each chiral center. And so to do that, we just give the locant, or the position of the chiral center, before the configuration. And so when I add this methyl group here, this chiral center is S, and so then this would be 2R, 3S, 2-fluoro-3-methylpentane. So let's do a couple examples on the next slides. Okay, so we want to give the IUPAC name of the following compound. We want to also give the R and S configuration for any chiral center. So just like any other molecule, the first thing I want to do is determine the parent chain. So I have 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So it doesn't matter which way I go. My longest chain will be 7. So I have a heptane. All right, and I want to decide which end to number from. So if I were to start from this end, I'd have 1, 2, 3, 4 for my first substituent versus 1, 2, 3. So I want to start numbering here. So my two groups are, I have an ethyl at position 3. I have a chloro at position 4. So then I would have, in alphabetical order, fluorochloro, 3-ethylheptane. And so this is what we would have done before. And so the only thing that we're going to add now is, right, this carbon is not chiral because I have two ethyl groups coming off. So I only have one chiral center. And so to assign that configuration, right, I think the chlorine is going to have priority 1. This would be priority 2. This would be priority 3. The hydrogen is on the wedge at priority 4. So I need to remember when I determine the configurations, I need to do the opposite because I've got to switch the, because the hydrogen's not in the back, right? So when I look at this, I say, okay, 1, 2, 3, looks like I'm going clockwise, right? But because the hydrogen is on the wedge and I really should have switched them to do the configuration, it's going to be the opposite. So instead of being R, this is going to be S. So I just need to give S 4-chloro-3-ethylheptane. And because there's only one chiral center, I don't need to give a number on where the S is because there's only one possibility. Okay, same thing, want to give the name of this compound. I think what's going to be different here is I have more than one chiral center. So just kind of looking ahead, I have a chiral center here, I have a chiral center here, and even though they put these on wedges and dashes, because this carbon has two methyl groups, it's not in fact chiral. So I have two chiral centers. So in this case, I think the cyclopentane is going to be the parent chain. I don't have any straight chains longer than 5. And for the numbering, I can either go 1, 2, 3, 4, or 1, 2, 3, 4, right? Those two numbering patterns will give me the lowest possible numbers, and they're tied right at 1, 2, 4. So then to break that tie, the first substituent I want to be the lowest alphabetically. So because the B in bromo comes before the I in isopropyl, I'll give this number 1, and so my number will be 1, 2, 3, 4. All right, and so then I have at position 1, I have a 1 bromo. I have a 2 isopropyl, and then I have a 4,4 dimethyl. So when I put everything together, I'm going to have, let's write it down here, 1 bromo, 2 isopropyl, and then 4,4 dimethyl cyclopentane. And then I have these 2 chiral centers. So I need to assign those configurations. So I have, I think if I do 1 first, I'm going to have priority 1, 2, 3, and then hydrogen's in the back. So I'm going 1, 2, 3 clockwise. So that carbon is R. Then when I consider this chiral center, let's see, this carbon is connected to 2 carbons. This carbon is connected to a bromine in a carbon. This carbon is just connected to 1 other carbon. So I think my priorities for this one, let's see if I can do a different color. So I'm going to have, that will be priority 1. That will be priority 2. That will be priority 3. Right, and then I've got the H at priority 4, right? So whatever I assign, right, because I'm going to have to end up switching these 2, so then now whatever I assign the configuration to be, it's going to be the opposite. So it looks 1, 2, 3, looks clockwise, looks like I'm going R, but because the hydrogen is in fact in front, it's going to be the opposite. So this is going to be S. So to finish off my name, I just need to put the configurations in the front. And so here I have 1R, 2S, and then the rest, 1 bromo, 2 isopropyl, 4,4 dimethyl cyclopentane. Okay, one final example. Sort of looking ahead, I think I'm going to again have 1, 2 chiral centers. But that's getting a bit ahead of ourselves. First, we'll find the longest chain. So I have either 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think the 9 is going to be my longest chain. Determine the numbering. Right, I think this will give me a substituent on 2. This wouldn't give me a substituent until much later. So we're going to number it 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, I have 2 substituents. I have an ethyl at position 4. I have a chloro at position 2. So if I put those in alphabetical order, I have 2 chloro, 4 ethyl, nonane. And I need to assign these configurations. So let's do the one at the top first. Let's use red for that. So I'm assigning this chiral center. So I think the chlorine is going to be 1. This carbon will be 2. This one 3. Again, I've got a hydrogen on the wedge, so it's going to be the opposite of what I assigned this configuration to be. So 1, 2, 3 going counterclockwise. This looks like S, but because the hydrogen is in fact on the wedge, it needs to be the opposite. So this is going to be R. We'll use blue for the other one. So assigning this chiral center. So I'm essentially tied at the first position, right? I have a CH2, I have a CH2, I have a CH2, right? They're both connected to, in each case, they're connected to a carbon and 2 hydrogens, right? It's connected to a carbon and 2 hydrogens, a carbon and 2 hydrogens. So then I go on to the next one. And so now I'm looking, right, to break that tie here, here, and here. And so now the one on the top, it has a chlorine. So that's going to beat out either 3 hydrogens or just another carbon and 2 hydrogens. So my highest priority is going to be here. When I compare these two, I've got 3 hydrogens attached to this carbon. I've got a carbon and 2 hydrogens. So going this way, it's going to be 2 and 3. In this case, the hydrogen is in the back. And so I don't need to swap anything. I have 1, 2, 3. So this is going to be counterclockwise, so that's S. And so then to finish off my name, I would have R 4S 2-chloro 4-ethyl nonane.